Hello everyone, this is the TI-84 guy. I'm back with another video. This video is going to be about the Alinear program that I wrote. I've made quite a few changes to the program during the summer to improve it, and I created some videos to support those changes. But what I decided to do is I wanted to go and have one video on this program that basically shows you not only some of the basic features, but also I wanted to show the changes that I've made and kind of put that all into one video. So I'm going to go over 12 questions from the SAT. And also I've included a couple of questions from SAT Math Level 1 and SAT Math Level 2, just to show you that the program is also useful for those tests as well. I'm going to do 12 problems in total. So, and I'm going to show you pretty much all the functionality of the program. So let me jump into it because this is definitely going to be a little longer than my typical videos. So let's just start. All right. So the very first problem I'm going to do, this was taken from practice test number 5. Let's see here. Let's get blue. It's coming from practice test number 5, and it's a number 6 question. So this one is a kind of relatively straightforward question. It says a online bookstore sells novels and magazines. Each novel sells for $4. Each magazine sells for $1. If Sadie purchased a total of 11 novels and magazines that have a combined selling price of $20, how many novels did she purchase? All right, so first thing I'm going to do is I'm going to write some variables. So novels is going to be, I'm going to put an N for novels, I'm going to put an M for magazines, and that stands for the number of novels and the number of magazines. Now, I have to come up with 2 equations, 2 linear equations. So the first one is going to be $4 for every novel, $1 for every magazine, and we spent a total of $20. All right, my next one is going to be the number of novels plus the number of magazines is equal to 11, because that's the total we have. Now that I have this system of equations, and these are both in standard form, I can go now to my calculator and I can use the Alinear program. So let's do that. So here, first thing you're going to do is press program. Very first program is Alinear, and I did that on purpose because the Alinear program is by far the most useful program for the SAT, and I wanted that to come up to the top. I didn't want you to have to search for it. So press enter again, and then now we're going to use option 5, system of equations. So we're going to choose 5, and they were both in standard form. So the coefficient was $4 for novels, $1 for magazines, and we spent a total of $20. Okay, the next equation also in standard form, the number of novels that we have plus the number of magazines that we have equals 11. When I press enter, it tells me that the number of novels, which is X, is 3, and the number of magazines was 8. So if I go back to the exam, I would choose 3. All right, so once you come up with the system of equations, you can use Alinear. All right, next question. Now, here is where I've made a couple changes this summer, and I want to go over it. This question is being taken from the SAT Math Level 1 exam, and it's basically to show you that you could also use the Alinear on the Math Level 1 exam or Math Level 2 or the ACT. So let's go through this one, and I want to show you how you can use your calculator for this one. So you have a system of equations here, and it says for which of the following values of K will the system of equations have no solution? So we're looking for no solution, and basically what that means is the lines have to be parallel because parallel lines don't intersect. So what we're trying to do is we're trying to find what value do we need to put in for K to make these 2 linear equations parallel to each other. So we got a system, so now we're going to go back to the calculator and we're going to press enter again. and we're going to use system of equations. These are in standard form. So again, we're just going to enter the coefficients. So the first one was 2, a -5 for the second part, and then the constant was 8. Press 2 again, and now the coefficient for the x term was 4. The coefficient for the b term is actually a constant, k. So I click alpha, and then I press the parentheses to get the k, and then the constant was 17. Once you've done this, the program is going to figure out what k has to be. And it says that k has to be equal to a -10 so that these two will be parallel to each other. So if I go back to the actual question, it would be letter A. Okay, pretty straightforward. Okay, let's do one more that has system of equations. Now, this one was taken from the practice test number 10. It's a number 35 question. So on a scale of difficulty, this is considered a relatively difficult question. And so let's read it and then let's see how we would use the calculator program. Okay, it says, in the equation above, A and B are constants. If the equation has infinitely many solutions for X, what is the value of B? So we've got two unknowns in this. And so what we're going to do is we're going to run the program twice. The first time we're going to solve for A, and then once we solve for the value of A, we're going to plug that back in, run the program a second time, and come up with the value of B. So let's do that. So I'm going to go ahead and distribute this. So I'm going to write it AX plus AB equals 4X plus 10. Now, you can only use one variable at a time. So what I'm going to do is I'm going to replace the B with a 2. You can choose any number for this, but I'm going to use 2. So this is going to be AX plus 2A equals 4X plus 10, right? Now that I've got that, I'm going to go and I'm going to use the program. I'm going to figure out what the A is, and then I'm going to come back to this equation and I'm going to replace the A with a 4 and then solve for B. So let me show you how I would do it. So here, go to the calculator. I'm going to press enter, option 5 again. These are in slope-intercept form. So we're going to press enter. The slope is an A, the constant A. And then the y-intercept is going to be 2A because we substituted in for B. And then we're going to do the right-hand side of the equation. The slope is 4. The y-intercept is 10. Press enter, and it tells you that A must be 4. So now that I have this, I'm going to go back and plug it in for the A and replace and put the B back in. All right, so let's do that. So I'll press enter again. My mouse is very sensitive, so when I click sometimes it runs ahead of me. So system equation, slope-intercept form. So what we have here is it's going to be 4. And then for this, it's going to be 4. And now we're putting the B in because this is what we want to solve for. And then we're going to do the same thing that we did before. The right-hand side was 4 for the slope and 10 for the y-intercept. You press enter, and it tells you that B has to be 2.5 or 10 divided by 4. Same thing. All right, so if I go back to the test now. This is a grid-in problem. So B is 2.5, or you can say 10 divided by 4. Same thing. All right, so now that's how you would use the system of equation part. It can handle one solutions, it can handle infinite solutions, it can handle no solutions. Okay, next. All right, so this problem was taken from March 2020, and I made a change to the program again to handle outputs of equations that are in standard form. So let me show you how I would do this. So it says an equation of the graph shown, the equation of this graph is AX plus BY equals 6, where A and B are constants. What is the value of B? So we're trying to find the value of B this time, but in this case, they didn't give us a system, they gave us a graph. and we have to put it into the standard form. So what I would do is I would just find 2 points on the line. This would be 0, a -2. This would be 6, 0. And I'm going to put this, now that I have 2 points, I'm just going to go to my calculator, press enter. I'm going to choose option 1 now because I have 2 points on that graph. And the first point was 0, a -2. The second point was 6, 0. Now, I want the equation of the line, so I'm going to press enter. Now, here's another change that I made. So now you have 3 formats. You can put the equation in slope-intercept form, and the slope and the y-intercept will be decimals if they're decimals. Or you can choose option 2, and it'll also put it in the slope-intercept form. But if there are fractions, it'll put it in as fractions. And then 3 is in the standard form. And this is the one we want. We want 3. So we would choose 3, and it tells us that the A coefficient is 1, the B coefficient, or the coefficient for y is a -3, and the constant is 6. And we were looking for the coefficient of the y term, so it's going to be a -3. So if I go back to the test, right here, B is going to be a -3. So that's your answer. And that's how you would use the 2 points piece. Now I have a couple more questions that demo the 2 points, because this is definitely the most, probably the feature that you'll use the most on the Alinear program, that and the ratios proportion piece. All right, now, so what we have in front of us, this is also taken from March 2020 exam. It's a number 20 question, and it's a scatter plot. And they want us to come up with the equation for the line of best fit, okay? So now, here's what you guys should do. If you're taking this exam and you have a scatter plot and you're trying to come up with the equation, you should try to draw a line. And if you are smart, you're going to take at least a couple of number 2 pencils. I would use one of my number 2 pencils as a ruler, and then what I would do is I would try to draw the line of best fit, something like this. I think that's a little low, so let me try it again. That's okay. Actually, that's a little old, but I'll fix it this way. I'm gonna move it up something like this. All right, that's probably a little better. All right, so now what I'm gonna do once I've got that is I need 2 points. So I'm gonna choose this point right here, and I'm gonna let's choose this point right here. So the coordinates for this would be 5 and let's say 97. And for this one, it would be 6.8. And that's a little short of 125. I'll say 124. Okay, now that I have 2 points, we're just going to do what we did in the previous problem. I'm going to go to the calculator and enter these. So let's go. So press enter, 2 points again. The first one is 5 and 97. The second point was 6.8. And we said about 124. Press enter. And now we want the equation of the line, and we want the slope to be in the decimal format. So we're going to choose option 1. And it tells us that the slope is about 15 and the y-intercept is about 22. So let me write that down. Y equals 15x plus 22. So now let's go back to the exam and see if we can find that. All right, so here are our equations. You know that A is not right because it has a negative y-intercept, so that's not right. Also, same reasoning, it's not C. So we got 2 choices. What I would say is the slope was 15. So this is way too small, so you can eliminate that one. The slope for this one is 16. Y-intercept we calculated 22. This one has 15.2, but that's the closest one. So the answer for this one would be D, okay? So that's how you use 2 points to come up with the equation for a line of best fit. Let's keep moving. Here, this was also taken from the March 2020 exam. It's a number 36 question. And basically, it's a linear function. And let's read it and see what we need to do. It says a linear function f is defined by f of x equals cx plus d, where c and d are constants. If f of 50 gives us is equal to 27,000 and f of 100 is equal to 38,000, what is the value of c? And in this case, excuse me, c is the slope. So here's what we're going to do. Set up a quick table, x, f of x, the input. When the input is 50, the output is 27,000. When the input is 100, the output is 38,000. All right, so we've got that. We are all good. Now we're just going to go enter this table of data. We're going to press enter. We're going to use option 1 again because we have 2 points. When the input is 50, the output is 27,000. When the input is 100, the output is 38,000. Press enter. We want the equation of the line, and we want to find the slope, so we're going to choose this, and we can choose option 1. It tells us that the slope is going to be 220. So we will go back to the exam, and that's what we're going to grid in. We're going to grid that in. Because this is a grid-in problem, so C is going to be 220, and we're done. All right, so let's keep going. Now, this question I saw when I was going through the Math Level 2 exam, and I thought it was a great question to show the flexibility of the Alinear program. Okay, so let's do this one. It says, it's a number 44 on the Math Level 2 practice exam, and it says, if the points 2b and 2b, comma 3, and b plus 3, comma negative 2, and b7 lie on the same line, so we know it's a linear function. What is the value of b? So basically, these points are all on the same line, so we know it's a linear function. And what we're trying to do is figure out what the values of b are. So here's how I would do this. I'm basically going to enter these as points. And because there are variables in there, I'm going to use this third point to figure out what the value of the variable is. All right, so let's go back to the calculator again. We're going to press enter. We're going to enter 2 points. Now, this is one of the changes that I've made. You can now enter letters other than X for this. So we're going to do alpha. It was a B. Actually, it was 2B. So let's do that. Right, 2 alpha B. And then the y coordinate was 3. The second point was, it was b plus 3. And then the y coordinate was a negative 2. Okay, now once you do this, in order to solve that, you have to either know the slope or you have to have a third point. In this case, we were given a third point. And the third point has a variable in it. So we're going to put that alpha b and then 7. All right, now all we have to do is press enter and it's going to figure out what b is. Well, before we do that, this is a good point. We should use the answer choices and make sure that we choose something that's in the range between the lowest answer choice and the highest answer choice. So the lowest answer choice was a negative 2. The highest answer choice is 4/3. So I'm just going to put 1.1. Doesn't really matter what I choose as long as it's in the middle of the choices. And then I press enter. And then it tells me that B, it's just overlaid by the cursor, B is equal to 1.333, which is the same thing as 4/3. So if I go back to the, if I go back to the test, my answer is going to be E, okay? So this program is flexible enough to handle variables in the points. If you have 2 points or 3 points, well, if you have variables, then you have to have 3 points in order to figure out what the variable is. But the program can handle it. So, all right. I hope you guys understand how important that is. Okay, let's keep moving. All right, now, here's the second most common kind of question on the SAT that you'll see. This question was taken from practice test number 5. It's a number 3 question, so it's a pretty simple question, but I wanted to show you how to use the functionality of the Alinear program. So let me read this and then let's go over it. It says to make the bakery signature chocolate muffins, it says a baker needs 2.5 ounces of chocolate for each muffin. And then it says how many pounds of chocolate are needed to make 48 signature chocolate muffins. And it says a pound is equal to 16 ounces. Now, here's one of the things that you guys should realize. Whenever they give you a conversion, like 1 pound is 16 ounces or 1 mile is 5,280 feet, anytime they give you like a conversion, you can set up a proportion to solve the particular problem. So that's what I'm going to do. So what I'm going to do is 2.5 ounces make 1 muffin. And we want to make 48 muffins, and we're trying to figure out how much chocolate in pounds we need. Now, you can see that the units are different. So what we need to do is we need to either, after we solve this, we have to convert it to pounds, or we can do it all in one step. And what I would do, I'm going to change this color, is just divide this by 16, and that'll convert the 2.5 ounces into pounds. So let me show you how I would do that with the calculator. So press this, go here, and what I'm going to do is press enter. Now we're no longer using the 2 points option. We're going to use option 4 for proportion. And what I'm going to put in is going to be 2.5 ounces divided by 16, which converts it to pounds, gives me 1 muffin. And then I want to know how many pounds of chocolate, and I'm going to use X. You can put in pretty much any variable. Does it take to make 48 chocolate muffins? All right, so that's the proportion that I set up. Now I'm just going to solve it. And it says that the amount of chocolate you need is 7.5 pounds. I would go back to the actual exam, and I would circle 8 and keep going. All right, let's keep going. Let me get my iPad to orient. All right, so now these questions, 37 and 38, were taken from practice test number 10, okay? So basically, they're the last 2 questions on the math exam. And so generally the number 37 and number 38 are generally considered a little bit more difficult. So let's read this and see how we can use the Alinear program. It says the peregrine falcon can reach speeds of up to 200 miles per hour. Important fact, while diving to catch a prey, making it the fastest animal on the planet when it dives. Okay, so question number 37 says, what is the peregrine falcon's maximum speed while diving to catch prey in feet per second? So what they want us to do is they want us to take this 200 miles per hour and they want us to convert it to feet per second. And again, they give us this conversion. 1 mile is equal to 5,280 feet. So now that means that we can use that to answer this. And we can use the proportion. So what I'm going to do, let me make this red. So we're going to have 200 miles per hour is equal to X feet per second. All right, that's what we want to do. Now, we've got 2 unit changes that we need to make. So here's how I'm going to do that. I like to try to do it all in one step if I can, if it's not too complicated, and I don't think this one is. So, so here's what I'm going to do. I'm going to erase this 1 hour. So 1 hour, so there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So there's going to be 3,600 seconds in 1 hour. It's equivalent to 1 hour. Now, the other thing that they told us is that 1 mile is equal to 5,280 feet. So if I have 200 miles, if I simply multiply this times 5,280, this will tell me how many feet I have now, okay? So now I've got my proportion. I can go to the calculator and just enter it. So I'm going to press enter. I'm going to use option 4 again. My first entry is going to be 200 times 5280. So this gives me the number of feet. And the second part is 3,600 seconds. We want to know how many feet per second. So the how many, I'll put an X there. And then I'm going to put 1 because it's per second. And then it tells me that the speed is going to be 293 miles per hour approximately. We're rounding this to the nearest whole number. So X is equal to 293 feet per second. And let's go back to the test. And I've written here 293 feet per second. So that's what you would grid in, 293. Now let's look at the second part. 38, it says if the peregrine falcon dove at a maximum speed for half a mile, so it's a half a mile that he's diving, how many seconds would the dive take? All right, so again, we're going to set up a proportion and we're going to use this. So it's going to be 293 feet per second. And we want to know if he dives a half of a mile. So I'm going to take 5280, which is 1 mile. That didn't look too good. I'm going to make this 5280, and then I'm going to divide that by 2 to make that half a mile. And then we're going to find out how many seconds it's going to take. So that's the proportion that we're going to use. So now I would just go back to the calculator. Once I've set that up, go back to the calculator, press enter. We're going to use option 4 again. It's going to be 293 feet. Oops. I put in 290. I want to make that accurate. So I start over 4. So that'll be 293 feet per second. And we went half a mile, 5280 divided by 2. And notice that I'm just entering that stuff, right? I'm just letting the calculator calculate all that stuff. I don't need to do anything except key it in. And then I'm going to put an X here. And it tells me that it takes approximately 9 seconds to dive a half a mile at maximum speed. So if I go back over here, I would grid in 9. And let's go back to the actual calculator. And I would put in 9. That would be the answer. So we used the Alinear program twice for the last 2 problems on the practice test 10. Okay, let's keep going. We're almost done, guys. I think there's maybe 3 questions left. All right, so this question was taken from the SAT Math Level 2 exam. And I just wanted to show you that you could also use the Alinear program when you're if you are taking a Math Level 1 or Math Level 2. So let's read the question and go through it. It says the radius of the base of a right circular cone is 6, and the radius of a parallel cross-section is 4. If the distance between the base and the cross-section is 8, what is the height of the cone? Now, I tried to draw it, and I think this looks pretty good. So this is what we're trying to find. We're trying to find the height. We know that the radius for the base is 6, and then we know we have a cross-section that's parallel that it has a radius of 4, and the distance between these two is going to be 8 units, okay? So the distance between these are 8. Now, what you should realize is that you have 2 right angles, bam, here, and they both have common angles, so these 2 are similar triangles. Similar triangles, the sides are proportional, so because the sides are proportional, we can use the Alinear program. And this is how I would set it up. I would say the radius of the small circle to the radius of the big circle is equal to the height of the small circle, which is this, and to the height of the big circle. Now, you see that we have 2 unknowns in there, but we should be okay. So we would go back to the program, and we're going to use option 4 again, since the sides are proportional, and we're just going to enter in the sides, 4, 6, and then it's going to be, I can put h minus 8, just to show you, you can use another letter, and then you can put in h for that, and then press enter, and it says that the height of the white cone is 4. So if we go back to the test and we take a look at it, we would choose option E. All right, so the height is 24. Okay, I got a couple more questions and then we're gonna be done. Let me orient this. Okay, this was taken from practice test 5. It's the number 28 question. And here's what we're trying to do. They've given us a graph of a linear function, and let's read it and see what we need to do. So it says the graph of a linear function f is shown in the xy plane above. The slope of the graph of the linear function g is 4 times the slope of the graph of f. So this is f, and it says if the graph of g passes through the point 0, -4, what is the value of g sub 9? So basically, when the input is 9, what's the output going to be for the g function? The g function is not shown, but what they tell you is that the slope is 4 times the slope of this. So we need to figure out the slope of this line first. You could use the program and just come up with 2 points, like here and here. But what I'm going to do is I'm just going to do rise over run. So we go up 1, and we run. We rise 1, we run 2. So the slope is going to be 1/2. And we know that g, the slope of g, is equal to 4 times 1/2. And so now that we know the slope and we know a point, we can go ahead and use our calculator now. So let's go back to the calculator. And what we're going to do now is going to press enter. And now we're going to use option 3. Point and slope, because that's what we know. And the point that we go through is 0 and -4. And the slope is 4 times the function f, which is 1/2. That slope was 1/2. And now what I want is, I want to know, so here are my options. We can come up with the equation of a line. We've used that. We can solve for y, the output, if we know what the input is. We can solve for the input, option 3, if we know what the output is, or we can find the x-intercept. In this case, we're going to use option 2 because we know what the input is, and the input was 9. So once we do that, it tells us that the output has to be 14. So if we go back to the test, we would circle C, 14. Okay, so that is when you know a point and the slope. Okay, one more question and then we're going to be done here. All right, let's look at this one. All right, this is from the practice test number 6. It's a number 35 question, which is a grid-in question. It says the line with the equation 4/5 x plus 1/3 y equals 1 is graphed in the xy plane. What is the x-coordinate of the x-intercept of the line? All right, so they've given us an equation and it's in standard form. So we can use that option and find the x-intercept. All right, so what we're going to do, we just go to the calculator again. We're going to press enter. Now, in this case, we're going to use option 2 because we know what an equation, we know what the linear equation is. So if we press that, the next question is, what was the format of the equation? Was it in slope-intercept format or was it in standard format? We were given the line in the standard format. So all you would do is enter in the coefficient. So this would be 4/5. The coefficient of the y term would be 1/3. And then the constant was 1. Press enter. Now, we're looking for the x-coordinate. So all we would have to do, we're looking for the x-coordinate of the x-intercept. So all we would do is just press 4, and it tells us that the x-intercept is 1.25. So we would go back to the test, and we would say, we would grid in 1.25, or you could also do 5/4, okay? Now, that's it. That's it, guys. If you've stayed with me through this entire video, I appreciate it. I want to go back through this real quickly because I want you to see something. Let's go restart here. Okay, this one didn't say it was linear, but once you look at this, you should know that this is linear. And because it's linear, you can use the Alinear program. Okay, the next one, this one said, if you look at these two, you should know that this is a line. These are lines. And because they're lines, you can use Alinear. And even though it's looking for no solution, you can still use Alinear, okay? Let's go to the next one. This one, same thing. It says these are two lines, and we want to know what value for B to make these have, or for A and B to make this have infinitely many. So this is why you can use Alinear. They're telling you here, we've got a graph of a line. So again, that's why we can use Alinear. Now they are, if you look at the answer choices, you can see that these are all linear functions, linear equations. And we're going to do the line of best fit, right? So you can use Alinear. All right, the next one, I hope you see the point. Linear function, we can use Alinear. Points on a line, we can use Alinear. This is a proportion. Direct proportions are linear, so we can use Alinear. Any proportion is linear. Direct proportion is linear. All right, we can also, again, these are proportions, so we can use Alinear. And finally, or actually we got two more, because these triangles are similar, which means they're proportional, which means we can set a proportion, which means they are also linear. So we can use the Alinear program. What else we have here? As you can see, they've given us a line, and then we're going to have another line that's steep, and they want us to find the output when the input was 9, so we could use Linear again. And finally, they tell us that it's a line, and they give us an equation, and they want us to find the x-intercept. So again, we can use the Alinear program. All right, so if you want a copy of the Alinear program, I think this is probably the most useful program you can take into the SAT. Honestly, I think out of all the things that I've written, this is probably the most useful. If you want to get a copy of the program, there's 4 things you need to do. First of all, send me your email address. Please make sure it's spelled correctly. Second, tell me what kind of calculator you have. Is it a TI-84 plus, or is it a TI-84 plus CE, or even if it's a TI-83, or if it's a TI-84 Silver Edition? Tell me what kind of calculator you have, because the size of the screens are different, so the outputs look a little different, and I need to know which program to send to you, okay? The third thing that I want you to do, if you would, I would appreciate if you would subscribe to my channel. And fourth, if you would like this video, that will help me reach more students, and that's my goal. I've created these programs to try to help students do as well as they possibly can on the SAT, the ACT, the PSAT, the Math Level 1 exam, the Math Level 2 exam. I'm trying to help. And the more likes equals more eyeballs, means I can help more students. So that's it, guys. Program is called Alinear. And if you want a copy, let me know, send your email, and I will get it to you as quickly as possible. If you are taking the exam on August this weekend, please send your information to me and I will turn it around as quickly as possible because I think you need to practice with the program before you go in to take the exam. So if you're taking it in August, I'll try to get it to you as quickly as possible. All right, guys, thank you. Be safe.